This presentation provides an overview of the geologic evolution of the Willamette Valley, the foundation of its terroir. About 50 million years ago, when today's western Oregon was still submerged under the ocean, an ancient basaltic ocean island chain collided with North America. That island chain consists of Silesia basalt that originated as submarine lava flows. The ancient islands rafted on the oceanic tectonic plate as it was subducting beneath the North American plate. The collision caused the Silesia terrain to become welded to the North American plate. That Silesia basalt is now the major component of Oregon's Coast Range. In the graphic on the left, the chain of Silesia basalt is indicated in pink. The gray shading on top of the pink area provides a perspective of the Hawaiian Islands for scale reference. Beginning approximately 46 million years ago, sediments were deposited on the Silesia terrain. These sediments originated from onshore rivers that carried clay, silt, and sand and deposited them as alluvial fans on the floor of the ocean. These sedimentary deposits are indicated in the graphic on the left as yellow fans located in the basin of the developing Cascade volcanic arc. The volcanoes are indicated as red triangles. Beginning approximately 40 million years ago, lava flows from the Cascade volcanic arc deposited basalt on the Silesia and sedimentary fans. Older Cascade lava flows are indicated in this graphic in light orange. Younger eruptions are indicated in dark orange. The sedimentary fans and ancient basalts are the predominant parent material of the soils found in the Yamhill-Carlton, McMinnville, and Van Duzer Corridor American viticultural areas. Between about 17 and 6 million years ago, stretching of the continental crust caused it to crack, releasing a flood of basaltic lava flows that blanketed large portions of what is today Oregon and Washington. These Columbia River basalts are the predominant parent materials of the soils found in large portions of the Chehalem Mountains, the Dundee Hills, and the Old Amity AVAs. The chart at the top of this slide provides a schematic cross-section of the geology from Tillamook to the Tualatin Basin. As the oceanic plate subducted under the continental plate, the Silesia basalt was uplift to form today's Coast Range, indicated in the center. The dotted line on the top chart indicates the original extent of the various geologic formations in the cross-section. Over time, erosion exposed today's geology. The lower chart indicates surface-level geologic formations from the Coast Range to the Tualatin Basin. On the left, the McMinnville area alternates between diabase basalt and marine sedimentary formations. Areas around Yamhill and Carlton are predominantly the Yamhill sedimentary formation. East of Carlton are the Cowlitz, Kesey, Pittsburgh Bluff, and Ribbon Ridge sedimentary formations. The sedimentary formations transition to Columbia River basalt at the Chehalem Mountains. Between approximately 20 and 15,000 years ago, much of the valley floor was covered by silt deposits from the Missoula floods. At the end of the last ice age, glacial dams catastrophically failed at least 40 times, filling the Tualatin, Willamette, and Lower Columbia basins with floodwaters, indicated by the blue shading in the picture on the right. A thick blanket of silt was deposited at elevations as high as 400 feet. This slide provides a summary of the major geologic formations that are the foundation of vineyards in the Willamette Valley. The Siletz basalt was created under the Pacific Ocean beginning 56 million years ago. Various layers of marine sediments were laid down between 46 and 20 million years ago. Lava flows from the Cascade Arc volcanoes created various basalts beginning 40 million years ago. The massive lava flows that created the major portion of the Columbia River basalts were approximately 17 to 15 million years ago. Around a million years ago, powerful winds deposited fine-grained loess silt on the eastern side of the Chehala Mountains. The Missoula floods and various landslides are relatively recent phenomena. Over time, exposed geologic parent rock weathers and erodes into soils. Water, wind, temperature changes, chemical interactions, and living organisms all contribute to breaking down the parent material into soil. In the upper portion of this picture, you see vegetation growing on 1 to 2 feet of soil. The bottom portion reveals sedimentary parent rock that was exposed about 15 years ago by a road cut. Early stages of soil formation can be observed on the sedimentary rock. The perspectives provided in this presentation were developed by Ray Wells and his associates at the U.S. Geological Survey. The graphics and narrative are available in a poster format in the link provided on this slide. Thank you for your interest in the Willamette Valley. Please make it a point to enjoy Willamette Valley wines.